Hello, 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 hello.
We request all the participants to take their seats. We request all the participants to take their seats. Thank you.
Now, I could like to introduce our next speaker. We are honored to have with us Dr. Rajeshwar S. Machi sir, Chief Scientist and Head of the Department of Food Packaging Techniques at CSIR, Central Food Technological Research Institute, Mysore. Sir is a distinguished scientist with over 3 decades of professional experience in food packaging research and development. Sir began his academic journey in agricultural engineering, pursued advanced studies at IIT Delhi, and has since built an illustrious career at CFTRI, contributing significantly to research, innovations, and technology transfer in the area of food packaging. Sir's expertise, bioplastics and biodegradable material, active and intelligent packaging, shelf life protection, and life cycle assessment, with several research publications and patent technology to his credits. Today, Dr. Rajeshwar S. Machi sir will be delivering a talk on bioplastics, biodegradable, and life cycle assessment, a topic of immense relevance in the move towards sustainability and environmentally responsible food packaging. Due to unexpected flight cancellation, Dr. Rajeshwar S. Machi sir was unable to join us in person. However, he will be continuing his session through online mode.
ஹலோ, இது வந்து யூடியூப் கேட்கும், ஓகேவா? இது பேசுறதுக்கு இதில் தான் பேசணுமே. இப்போ இங்கே இருக்கவும் கேட்குறதுக்கு அங்கே ஒருத்தர் பேசணும்னா இங்கே ஆடியோவில் கேட்கணும், இந்த ஸ்பீக்கரில் கேட்குறதுக்கு.
அங்கே உள்ள அவர் பேசுகிறது
அது கேட்கணும். சரி,
நீ எனக்கு புரியல, நீ என்ன சொல்கிறதுன்னு எனக்கு புரியல.
Yes, sir, we can hear you. Sir, we can hear you.
யாராவது கொஷின் கேட்கணும்னு நினச்சாங்கன்னா அதை மட்டும் கொடுத்துருங்க. ஆனால் மைக்கில் மற்றபடி பேசாது. இதெல்லாம் கொடுத்துட்டாங்க. இதெல்லாம்
sending it to me. Make him present up for the
சார், அது அவர் மைக்
ஆடியோ பார், ஆடியோ அட்ஜஸ்ட்.
So, good morning. Can you hear me?
Good morning, sir.
Good morning, sir. We can hear you, sir. Sir, we can hear you, sir.
You don't hear me. Hello. I'm able to hear you. I don't know why you are not able to hear you.
Sir, we can hear you.
Just give me. Can you speak here? I will log in another
Hello, sir. Hello. Good morning, sir.
Hello.
We can hear you, sir.
இது மைக் ஆஃப் பண்ண மாட்டோம்.
அந்த மைக் இதெல்லாம் பிரச்சனை, அந்த மைக்கை மட்டும் ஆஃப் பண்ணுங்க. கூடிய மைக்கை மட்டும் ஆஃப் பண்ணுங்க.
ஹலோ சார். பட்டன். ஹலோ சார். ஹலோ.
இப்போ எதுக்கு இதில் மெயின் ஆடியோ மெயின்
இல்லை, இது மைக்கில் லேப் மைக்கில் தான் பேசுகிறேன்.
லேப் மைக்லேயே பேசுங்க. வருங்க உங்களுக்கு
கேட்கல.
ஆடியோ 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 தான் மியூட்
சவுண்ட்
அது ஸ்பீக்கர் சவுண்ட் பிரச்சனை இருக்கும். அப்புறம் பேசுங்க பேசுங்க.
பேசி ஹலோ சார். சார் ஹலோ சார். ஹலோ சார். மொபைல் ஆன் பண்ணிருக்கீங்களா? வச்சிருக்காங்க இந்த மைக் ரிசீவ் ஆகுது, ஆடியோ ரிசீவ் ஆகுது. நம்ம சைடில் வருது. மைக் இருக்கா?
மைக் இருக்கு. ஏய், ஓவர் த இயர்ஸ் பண்ணோம்டா. ஓவர் த இயர்ஸ் பண்ணோம்.
மைக் இருக்கா பார்த்துக்க.
ஹலோ.
Now I can see, but I'm not getting your voice. Yeah. So can you see this my screen?
Yes.
Oh, great. Yeah.
Sir. Can you hear us, sir?
Yeah, I can hear you. Can you see the screen?
Yes, sir.
Okay, great. Shall I go ahead with the presentation?
Yes, sir.
Yeah, very good morning. And thanks to the organizers, Head Printing and Packaging Department, Dr. Kanchan and Karthik. So, sorry for the technical glitch and sorry that I could not physically come there because of some issues. So, my discussion is divided into three parts. One is bio-based plastic. Then misconception regarding the bio-based plastics, biodegradation, understanding of biodegradation, and there are different types of biodegradation, and then the buzzword of biodegradation, how it is taken up, and then how the life cycle assessment is taking the lead, and why it's so rightly. That is where we will discuss. So we'll spend maybe 10 minutes to 12 minutes in each section. So coming to the point, when we are talking about bio-based material, there is a lot of misconception regarding the bio-based material. People always connect bio-based material with biodegradable material. So look at the definition of bio-based material. Any material which is coming from the feedstock originally. So they are bio-based material. Not necessarily all bio-based materials will be biodegradable material. For example, if you develop a polyethylene or feedstock, it is material from fossil fuel. So hence, the advantage of bio-based material is they have a lower carbon emission, but they get into the same infrastructure in terms of the recyclability. Coming to bio-based and biodegradable material, these are plant derived and they are compostable. You take like PLA or PHA, which are fermented from the microorganisms and using different life feed. So these are specialized for end of shelf life design. So they have limited applications. Now coming to another interesting matrix, if you are looking at it, is in terms of what you call it as a sustainability matrix. In the sustainability matrix, if you just see that here, these are all bio-based materials and they are non-degradable materials. They are very similar to the fossil-based, there's petrochemical-based materials. If you take bio-PE and you take normal PE, you will not see much difference in terms of the chemical structure. They are identical chemistry and hence they are the same material. So they go into the same infrastructure in terms of their recyclability. Coming to the matrix of degradability. So in the degradability matrix, the materials which are degradable, they can be bio-based like PLA or PHA or starch blends, or they may be fossil-based, that is PBET or PCl, PVA. Now they go into the same compostable infrastructures by which they are composted into the regular system, but they don't go for the recycling mechanism. And hence, if you look at the bio-based material and biodegradable material, their mandate and chemical structures are different. Now, if you look at the bio-based material infrastructure across the globe. Polyethylene dominates the bio-based materials which are non-degradable. They command around 14% of the bio-based plastics, and they are big players like the brand like I'm Green, that is a brand scheme, or even Dow Chemicals or BASF. They are the one. They are using the advantage of sugarcane. We'll say little more details. Similarly, bio-PET also is used by the big players like Indorama and Coca-Cola. Coming back to a little more granular details. So if you take bio-PE, this is basically, when you're talking of bio-PE, it is the basic thesis is the carbon reduction in the system. If you take a fossil-based materials, petroleum-based materials, the carbon footprint is high. So, but if you look at the bio-PE, the polymers, they have identical chemistry of the fossil plastics, and they are derived from the renewable feedstock. So if you take a sort of sugarcane, and then you, or any other starchy materials, and then you get by fermentation process, you do ethanol. And then from the ethanol, you dehydrate and get ethylene. And that ethylene, with a different pressure and temperature, you get a different types of polyethylenes. Can be high density, low density, medium density, and they are as good or bad as your normal PE. Now, what happens here? This has, as I said, 14% of the market in the bioplastic. Very important part where the whole Europe and India also is focusing to have a lower greenhouse effect emission versus the fossil fuel. This reduces around 40 to 60% of the greenhouse gases, and also it plays a role in terms of reduction with the bagasse as a co-producer. In the sugar industries, bagasse is waste material. That energy is used as sort of a co-product to get the bio-PE. But the story with bio-PET, that is the bottles which you see, is a little different. This generally bridges the gap to the 100% renewable. But if you look at the chemistry of the polyethylene terephthalate, it has two components as a raw material. One is terephthalic acid, and another one is ethylene glycol. Terephthalic acid as such today, you cannot get from biosource, and hence it has to come from the fossil fuel only. That is 70% of the raw material requirement. Only thing which can come from bio-based is your ethylene glycol. And this is available commercially. That means when if somebody is claiming PET as a bio-PET, it is free of the PET in the bio. Still is bio-based because part of the material is coming from the feedstocks, and it is basically a hybrid reality which allows 30% of bio-based material. Future development, the research can be to get the terephthalic acid also as a sort of a bio-based material, and hence you get the similar results with using bio-based materials. Coming to the biodegradation part of it. Generally, when you look at any material, if the biomass is there, and then you make the packaging material, it can be PLA or PHA. In the life cycle, it goes for the uses and it goes to the industrial composting. This can be any type of bio-based, means it will be generally a PLA or a PHA, or it can be blend with starches because it may not have the properties on its own. But then the disadvantage of this mineral is it is not like a drop-in. This cannot chemistry, so go into the same recycling or reuse systems, and hence it has to be segregated and treated. Now, apart from the bio-based biodegradable materials, there are fossil-based biodegradable materials as well. But the basic thesis of fossil-based this is non-biodegradable material, that is a baseline. This is a incumbent standards because they want a very strong material which generally doesn't degrade. You take the material of PE or take PET or PP or PA. They are basically derived from the crude oil or natural gas, and they are low in cost, but very high performance and requires mechanical recycling.